mass flooding, crazy heat waves, wildfires that engulf cities, complete habitat loss, and widespread species extinction. Is this all climate change? What is climate change, really? I'm going to start with the UN's simplistic definition of climate change, and then I'm going to make both of us smarter by giving you 2 additional definitions of climate change that tell a much juicier story of what's actually happening to our Earth. So here's the UN definition. Climate change is the long-term changes in the Earth's climate that are warming the atmosphere, ocean, and land. That's not bad. You know, climate change is the changes in climate. It's pretty smart. Nice work, UN. I do like how they say long-term here, because these are long-term, you know, over the course of decades, centuries, and thousands of years. And what's happening with it? Well, it's warming. Obviously, that's not the only implication. The CO2 in the atmosphere makes ocean acidification, which removes all the mollusk shells and stuff like that. But warming is most of the story. And what is it warming? It's warming the atmosphere, the ocean, and the land. I think this is not bad. It talks about the different geospheres, you know, the atmosphere, the hydrosphere, and the lithosphere. I don't love how it talks about land warming. It's kind of a weird thing. It's mostly the air and ocean get warm. The other thing I wish this had is that it should talk that it's man-made. That's anthropogenic. It's almost hilarious that they're like, this is just happening. It's like, no, we're doing this, people. So I want to add a second definition here. So the second definition is climate change is a delayed carbon pulse. Well, what does that mean? What does the carbon pulse mean, and what does delayed mean? So let's start with the big picture, this amazing data visualization of humanity's journey on Earth. You know, at the start of Sapiens 200,000 years ago, and then here we were in an ice age. It was really cold here, but then the Younger Dryas happened, the world got warmer, and we started to do farming. We had the agricultural revolution, which kickstarted the Holocene and human civilization as we know it. Then, you know, by 1850, we had the Industrial Revolution, and now what we've done is we've increased the temperature even more up to 1.2 degrees C, and we're going to 2.7 degrees C. So this is now us turning into the Anthropocene. And so I like to think of this rise in temperatures as clearly a result of the Industrial Revolution. We pulled all this carbon out of the ground and put it into the atmosphere, which is now warming our atmosphere. So this is a graph of global fossil fuel consumption. And what it shows is over time, how much coal, oil, and natural gas we've pulled out of the ground. By burning it, we've put that carbon into the atmosphere, heating our atmosphere. Now, a question you can ask with this graph is how much carbon can we pull out? Is this going to keep on going up and up and up? Or are we at peak oil? Or is this going to go down immediately? And when you ask that question, the answer is roughly that we're a third of the way through. So we've pulled out roughly, I think it's something like 200 terawatt years worth of fossil fuels out of the ground. You know, right now we're spending roughly 20 terawatts per year. And so we're pulled all this fossil fuels out of the ground. We have roughly, it's been about, 200 years or so. And at the current rates, we have maybe, 50 to 150 years worth of fossil fuels left in the ground that we can pull out at an economical rate that will actually continue to power us. And that's crazy. We're a third of the way through our fossil fuels. It's like when we've been given 3 marshmallows and we immediately ate the first marshmallow and we're about to eat marshmallows 2 and 3. And so this is what Nate Hagens calls the carbon pulse. This is now zoomed out slightly, but you can see here's the year 2000, here's 1500, here's 2500. There's only so much carbon in the ground. And so we're in this little time period, which is really crazy to exist at this time on Earth, where we've done this carbon pulse. We pulled it all out of the ground. We're spinning it all. We're just running cars that are like massive metal machines. And we're just like, yes, spend the oil on that. Why not? But very soon that carbon will go away. And in the meantime, we're obviously taking all this carbon and we put it into the atmosphere, warming everything. And so this is what we mean by climate change is a delayed carbon pulse. We pull this carbon out for energy, and then there's a slight delay where then all of that carbon heats up the entire Earth. Now, the third definition is climate change is selection pressure. And so what this means is that as the world gets hotter, we're putting selection pressure on the atmosphere, for which molecules are going to be stable in the atmosphere. We're putting selection pressure on the biosphere for what kinds of animals can exist in the biosphere. And we're putting selection pressure on ourselves for where we need to live in the world. So first, here's this amazing map of the selection pressure we've put onto the lithosphere. And so this is a graph of all the fossil fuels we've pulled out. Again, we've pulled out roughly a third thus far. And what we're doing is essentially putting selection pressure onto the ground. There's 6 million different holes in the United States, these little pinpricks that we've pulled oil out of. At the beginning, it was just flowing out of Pennsylvania. And now we have to try harder and harder to find these deep sea oil wells to do fracking, etc. But we're also putting selection pressure on the biosphere. So this is a graph of global land use for food production. And you can see that of the Earth's surface, it's 70% ocean, 30% land. Of all the land, it used to be, there's lots of glaciers and barren land. By the way, we're putting pressure on the glaciers and barren land, we're turning the cryosphere into the deserts. So by 2100, there's going to be no glaciers left. So of the habitable land, it used to be all forests and shrubs. But now we put selection pressure where we say, no, we're going to take about half of that and we're going to spend it on agriculture. A lot of that agriculture is for livestock to help our cows eat. And then the other, 20%, 16% is normal crops for food like, corn and rice. I think this graph does a good job of showing that selection pressure. Now, in brown are all the pastures that we have in the world. These are pastures where we raise animals. And then cropland is the land where we, here's the corn belt in the United States or whatever. Here's a bunch of cropland in India. So we've kind of taken the earth normally. We've left the forests up top. We've left the forests in the Amazon and then the Democratic Republic of Congo. We've left the deserts in the Sahara, in the Persian Gulf, and in Australia. And we've left the kind of glaciers up top in the Tibetan Plateau. But for most of it, we've kind of turned it into pasture and cropland. And so this graph shows the changing distribution of the world's land mammals. And you can see that 100,000 years ago, there were tons of megafauna, elephants and giant sloths and all these things. And then, 100,000 years ago, we killed a bunch of them. This is called the megafauna extinction, where Homo sapiens, whenever we got to new land, like North America or whatever, we'd kill all the mammoths there and all the buffalo there and stuff. And then today, it's even crazier, where we have almost no wild land animals left. You can go to Africa and see some elephants, but there's tons of humans out there, 10 billion humans, it's called 8 billion humans, and then tons and tons of livestock, which doesn't even include poultry, by the way. And so I like to think of this as mass selection pressure, where we've taken away the environments for wild land animals, and we've kind of killed these wild land mammals, and we've created these farms where we say, no, if you are symbiotic with us, we'll allow you to live in this farm and, milk you and make you big and then kill you. And so fundamentally, there is a selection pressure against wildness and a selection pressure for domestication. Now, I think this chart really shows the selection pressure against wild animals. This is the Living Planet Index, which tracks populations, the average decline in the abundance of populations by type of habitat. And so you can see from 1970 through now, across marine environments, terrestrial environments, and freshwater environments, overall, globally, the populations have gone down about 60%. So that means that if you are some animal out there in the world, there are half as many of you as there used to be just 50 years ago. So this is why you can imagine by the end of the century, we might be at 90% here, where there's a 90% decline in populations, with something like 15% of species going fully extinct. Yeah, and so this is the idea of the sixth extinction, and humans are fundamentally selecting against wildness. I think this is a great but sad piece of art that really shows that. Here's humans doing our oil thing and just kind of consuming all of the biosphere and all of the little animals. But in addition to climate change putting selection pressure on the geospheres and the biospheres, we're also putting selection pressure on us. This comes in two forms: heat and sea level rise. So here's a great graph that shows the impact of heat on humanity. And fundamentally, humans have grown up in a climactic niche. Yeah, so humans don't really live up north. We don't really live way down south. It's too cold in those places. We don't really live in the deserts. So we have these other climactic niches where it's not too hot, not too cold, but just right. But what this graph is showing is that as the world gets hotter, we're going to be pushed out of our climactic niche. So the bottom graph is at 1.5 degrees C of warming, which is, we're already at 1.3, 1.4. So this is pretty much happening now or by 2050. And then we're also going to have 2.7 degrees C of warming by 2100. And so you can see here, here's populations of the world. The red is where there's lots of people who live. This is in Nigeria and India and Bangladesh. And you can see the real issue here is this MAT above 29 degrees C. That stands for mean annual temperature above 29 degrees C. And this is bad. The Sahel gets really, really hot. The Persian Gulf gets really, really hot. Southern India gets hot. That's already happening now and soon. This is why, 1,000 people or whatever died at Mecca recently during the pilgrimage. But then at 2.7 degrees C of warming, this is by the end of the century, those shaded areas get even bigger. So all of West Africa becomes way too hot. All of the Amazon gets way too hot. Most of the Persian Gulf gets way too hot. Most of India gets way too hot. Also Pakistan and Southeast Asia and Indonesia. This is a hot world. And you see these 29 degrees C places, those are places where it's going to be too hot to live. And so we're going to have to move away from those places because of the selection pressure of climate change on us. But the other thing that's going to happen is sea level rise. And so in addition to moving away from the hot places, we're going to need to move away from the coastal places. This is a graph of urban populations at risk in the 2050s. And you can see here that, the red are where you have, the red and the yellow are large urban population centers. And so this is New York City and Los Angeles, and here's Lagos, and there's Kolkata, and so these are big places in the world. Here's Shanghai. And so the problem is that by 2050, 2100, we're going to have 0.5 to 1 meter of sea level rise, which if you imagine my body here, it's about up to my knee to my hip. And so we're going to have a good amount of sea level rise. And what that means is obviously some of the islands are just going to go away or whatever, like Kiribati, but also places like Bangladesh. This is why the people in Bangladesh are moving away from some of the flood-prone areas and are moving towards urban centers and are moving away from the coast. So I hope this helps you expand on UN's definition of climate change. Yes, it's the long-term changes in the Earth's climate that are warming the atmosphere, ocean, and land, but it's also this delayed carbon pulse where we're a third of the way through our fossil fuels, and it's this massive selection pressure on the geospheres, biospheres, and anthroposphere that is fundamentally turning the Earth into a reflection of humanity. Thank you, as always, for watching. And thank you to Roots donors for supporting this channel. If you want to understand more about the past and how we got here, check out the previous videos here. And if you want to understand the future and where we're going, feel free to subscribe here. Hope to see you then. Bye.